Hi guys, let's solve today's Leetcode problem, and it is problem number 3464. Maximize the distance between points on a square. Okay, this is a hard problem, but let's tackle this out. So you're given an integer side representing the edge length of square with corners at 0, 0, 0 side 0 and side. Okay, on a Cartesian plane. You're also given a positive integer k and a 2D integer array points where points of I, xi, yi represents the coordinate of a point lying on the boundary of the square. Okay, this point lie on the boundary of the square. You need to select k elements among points such that the minimum Manhattan distance between any two points is maximized. Okay, return the maximum possible minimum Manhattan distance between the selected k points. The Manhattan distance between two cells xi, yi and xj, yj is xi minus xj plus yi minus yj mod of these values. Okay, so this is the problem that is given, and here we have given the side, and the side says that this is edge length of the square, and our square would be 0 0 0 side comma side and 0 comma side. Okay, and this is the Cartesian plane, and if you see like these constraint as well, right? So constraint input is generated such that this point lie on the boundary of the square only. So these points will be only in the boundaries and the square, that the side that is given to us, nothing outside or inside of that. Okay, and all the points are unique. Okay, now we have also given this value k and this points. Okay, now what we have to do is among these points we have to select k points such that we can maximize the possible minimum Manhattan distance. So distance between two points is Manhattan distance between two points is this. Now we have to maximize the minimum distance. So this is the question. And if you see one few things, sides is up to 10 to the power 9. This points dot length is minimum 4. So minimum there will be 4 points. This one, and it can be minimum 4 till up to minimum of 4 into side and 15 into 10 to the power 3, whatever is minimum between then, between these two. So what I can say is at max this point dot length can be up to 1.5 into 10 to the power 4, right? That is the maximum value of point length that can be, because minimum of this or this, if this is maximum, this is the max it can be. And for k also, if you see, minimum value is 3, that 4 minimum that you have to select is 4 value, and at max it will be minimum of 25 or points dot length can be at max this much. Okay, so it would be minimum of 25 or this. So what I can say is that minimum of this maximum value for k can be 25. So k is less than equal to 25 till 4, and here it is from this value till 4. Okay, now if we see this example, so this example here, this is, we have to select 4 points and only 4 points have been given to us, so we don't have any choice, right? We have to pick all these 4 points, and when we pick these points, what is the minimum distance, the maximum minimum distance? So if you see among these points, it is all 2, everywhere it's 2. So the minimum is 2. Okay, basically maximum value is 2, minimum of all this is 2, and altogether maximum is. Now, if you see this example, here we have given this points and k is 5. Okay, so we have given 6 points, sorry, 7 points, and we have to select 5 points among them. And the side given is 2. So you see in this Cartesian plane, all the points are plotted here. And if we see any point, if we select, 5 points we have to select. Let's say if we select these corner points, 1 2 3 4, then again there is one point that we have to take. Now if we take either this point or this point or this point, any of this point if we take, right? So the distance between that point and the other point, it would be 1. Okay, it would be 1, it cannot be anything greater than that. So since we have to pick the other fifth point, it will become distance will become 1. So minimum distance for this point, due to this point, the minimum distance becoming is 1. Otherwise, if you have to pick just 4 point, so we could have simply picked this one, this one, this one, right? But now since among the remaining 3 points, you have to pick the fourth one as well. So any of this way, if we pick, so it would be minimum distance will be 1 for this point. And since for this point it is 1, so maximum altogether would be 1 only. Okay. So this is the another example. Now, how will we solve this problem, right? So one hint that is given in problem like itself is we have to maximize the possible minimum Manhattan distance between 2 points, right? Maximize possible minimum. Okay, so this clearly says, I mean, if you have studied about binary search on answer, so it says clearly that this is a binary search on answer problem. We have to apply binary search on the answer. Now let's, on the way we will identify that how we will apply binary search and what is the answer on which we will apply the binary search. Okay. Now, since you see all these points that are given to us, right? This is, I mean, based on constraint, all these point will lie in the boundaries itself, right? Now, what is distance between these 2 points? So this is the distance. This is the distance. If let's say there would be any point over here, so this is the distance, right? So minimum of all such distance, if you pick any point k, I mean you have to pick k point, right? K points I have to pick. So if I pick any point, let's say I have to pick 5 points, okay? A, B, C, D, E. Now among these 5 point, I will have this A to B, there would be some distance, A to C, A to D, A to E, right? So there will be some distance among these points. Now, what is the minimum value for this distance? Minimum distance. Let's say for this M1, right? Similarly, for this, there will be some distance, there will be some distance, and there will be some distance, and A to B is here. So there will be some M2 M2 is the minimum among all these distances, right? Manhattan distance we are discussing. So this is one distance, this is just another distance, and this is another distance. Among all these distances, it is M2. And similarly, minimum among all such would be like, minimum for point A to other points is M1. Minimum from point B to other points is M2, and so on, right? So altogether, max of M1, M2, M5, right? So this is our answer that we have to return. Now, here we have these 5 points, but in question, we have to pick that 5 points such that we get this max. Okay, so if you see, this is the point that is given. I mean, this is our array. This is side 0 comma 0, side comma 0, side comma side, and 0 comma side. And if you see in this line, y is 0. Okay, in this line, if you see x is 0, value of x is 0. If we go for this, this side, here you see x is side for all this. In this line, all this x value will have side. In this line, if you see, y will have the side. So here y is side. So this is the problem. You see here, right? This point dot length can be from 4 till this value, which can be max up to 10 to the power 4. Now, since it says that at minimum we will have 4 points. 4 points will be there. Now this is the square. Now if we have 4 points given, if we place, let's say, if you place these points in the corners itself, so this distance will be at max how much side, right? If you place like this. Now, because question says that at minimum there will be 4 points. Okay, now let's say if we have this, 4 points, if we don't place it at the corners, let's say I place it all here, 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 here. Now if you see, distance would be among these 4 points, this is the minimum. Okay, and this is the length, this is the length. So what is the minimum that can be possible? You see, one thing is that question itself says that minimum is, I mean, minimum for this point dot length is 4. So at max, if we plot this points like this, then it can, get this minimum distance between them is side. Because if any other possible way, if we try, there's these 2 points will come on the same line, and when they will come on the same line, so this is, let's say, the side of the square, and there was 2 points I have to place here. So at max, what can be the distance between them? At max, if I place 1 point here, 1 point here, this is the max, right? That we can achieve. If I place some point here and some point here, this will be definitely less than side, right? So which means that maximum possible answer in our case would be side. It is not possible that it can go greater than side, because we have to place 4 points. This is the maximum if we can place. If we place any other point, 2 points in one line, it will be, less than or equal to side. It cannot be greater than side, right? Even if we, let's say in this example, if you see, we have no points in this line, right? But since there is no point, we have to adjust 4 points in other lines, right? So this is the minimum that we get. So side maximum answer can be, in our case, the maximum can be side. Okay. So this is the max that can be up to side. What can be the minimum value? Okay, for our answer. This is the maximum. Minimum value, since our constraint or the question is given such that these points are integer points. Okay, this is not decimal points or floating points, which means the if I have here 0 comma 0, next point in this line would be 0 comma 1, or if I say in this line, next point would be 1 comma 0. It is an integer point, so minimum distance would be 1. It cannot be less than 1. Okay, so I know this is my, it will go from 1 till side. So this is my range. I mean, where my answer can lie. This is the answer for my range. This is here where my answer would lie. Okay. Now, since we see this problem, there is one more thing to observe. Here we have this point P1, P2, P3, P4. Now from this, what can be the minimum distance? Since we have derived that at max it can be side, nothing greater than side, which means there is some point over here, some point, let's say, in the opposite. Okay, opposite is somewhere here. Maybe let's consider this line. Okay, this is my line. Now for this line, what is the uh, m- since our answer can be max side, right? So if I am at here some point, my answer can go from points at max till here, some point place here, and here some place till here. But if I see something opposite this side, right? Opposite for this line. Here it would be, the distance would be here, it would be greater than side. And I know that my answer cannot be, that the distance, minimum distance cannot be greater than side. Okay. So I can simply discard this point. Okay. That opposite, I don't need to consider itself. So what I need to consider, my current line and the adjacents, adjacent lines. Okay. Here adjacent lines. This is what I have to consider. Okay, now if you see again on this Cartesian plane, this is my point. Now, if I go in this direction or I go in this direction, there is some point P2, here it is P1, P3, and P4. Now, let's say if I think of, uh, you know, because we are thinking somewhere to apply binary search on this question. One thing we have so far figured out that this is my answer, okay, on which I have to apply binary search. This can be, my answer. Now the question is that we have to pick these points, right, for that particular answer. we have to pick the points. Now if I pick this point P1, now if I pick this point P1, it can be you know P2, P3 and P4. But if I say that my answer is, we have got our answer. Now we will do binary search on that, right? This is my answer. For this answer, if I know my points are there or not. Okay. Basically, what is our answer from 1 till side, right? So let's say somewhere in between side by 2. So if we take above example, so there it would be side was 2, so it would be 1. Now for 1, what we are trying is that let's pick this point here where 1 can be the max limit. So next, the points that I have to pick should be greater than or equal to, this point. So if I pick this point, I can pick this point for sure. I can pick this point also for sure. Now if I pick this point next, from here I can pick this point because it is greater than, 1. The sides are 2 from our example. So I can pick this point. Now if I pick this point, I can pick this point as well, right? Because the distance is 2 and which is greater than 1. So yeah. And one thing, if you see, rather than, we can pick this way from here or we can pick this way from here. Rather than trying both the things, what if, since all these points are on the perimeters of the square, right? So points are in perimeter of square. Now what if we, overlap these points? Meaning I have these points, I start from here, I take these points in one line, then these points on the same line continuous, then these points and these points. Okay, this is a circular thing, right? Because we have to consider both the things. So I mean, if this example, if you take P4 was here, right? Now let's say if P4 was not here, instead P4 would have been here. So can we able to pick this P1 point accordingly? No, right? Because this distance would be less than 1. So this is not possible, right? So we have to try this such that these points that we are picking is, less than equal to whatever the limit that we have taken. Now let's try to plot these points in a linear uh, one dimension. So I said what we will do is we will first take the upside line, then right line, and then bottom, and then left. This is the arrow. Okay, so let's try plotting it. Now if we just plot this, so if you see, for we want to plot this line, right? So this one we discussed here, right? That this point here we have x0. So similarly we can write things something like, so if we just write our above example, one second, let me just write the above example. So this is how it is, and we have these points 0 comma 0 0, oh sorry, 2 comma 0 2 comma 2 0 comma 2, and there is one point here 1 comma 2, here it is 2 comma 1, and here it is 0 comma 1. Now let's try placing it. Okay, this is the direction that we are taking. For 0 comma 0, it here we say that, right, x is equal to 0 in this line, y is equal to 0 in this line. Now if we see, rather I would write it here, This upside we are taking, right? So x is equal to 0. Downside we are taking, so y is equal to 0. Sorry, not for downside. For this one, y is equal to 0. For this side, if you go, y is equal to side. And for this one, x equal to side. Yeah, so now let's plot this 0 comma 0. So 0 comma 0, I know if I just simply plot it here, so it would be 0. Now next point is 0 comma 1. Now how can I plot this here? This is actually uh, simple thing, plotting this 2D into 1, because these just line the boundaries, nowhere else. So here if x is equal to 0, then we can plot y into our line. If y is equal to side, you see this, x is equal to 0 for this one, so we took this one. Then for this one, y is equal to side. So if y is equal to side, what is the length for this one? If you see from here point, it is this side plus this point, right? So here it is 2 plus 1 3. Okay, from this point if we calculate the Cartesian distance for this, it would be 3. Okay, so it would be side, if y is equal to side, then what we need to plot is side plus y. Sorry, my bad, side plus x. Okay, and next is if x is equal to side, so this one, right? Now x is equal to side, this is the line where x is equal to side. Here if we see what is the point here, I mean how can we plot if we want to plot this as a line, right? So this is like side, this is one side, another side, three side, right? Now here if you see, x is same, y is varying, y is here 2 1 like that. So if I do 3 times side, 1 2 3 times side minus this value y, then I would be able to plot this, right? So it would be 3 side minus y. Now if we see this point, so what is this? This y is 0. So if y is 0, now if you see this point, how to plot this one again? This is one side, this is another side, this is another side, this is another. So 4 times this minus here, if let's say there would be some point, so it would be in this line, if you see, right, y is 0, right? Here y is 0, y is 0, y is 0. Some value it would be for x, right? So if I take 4 times this minus x, I would get that point, right? So it would be 4 times side minus x. Yeah. So in this way, I will be able to plot these points. So if I simply plot, so for 0, it would be 0. For this point, since x is equal to 0, we have to consider y, so it would be 1. Now for this point, here again x is 0, so it is 2, y we have to take. And similarly, if I plot, right, so it would come something like 3 4 5 and 6. Okay, you can just try this out. This is how it would look like. I have now plotted these points in the array. uh, okay, so the points that we would be given to us as not in any, it can be in random array, I mean random way. And since we want this direction to be followed, right, because we are plotting these points in this 1D array in such way that it follows this direction. Okay, so we these calculation which we'll do, it won't be in sorted manner because these points are not given in this manner, right, which we are calculating. If you see above, so we are calculating this upside, up arrow, right arrow, bottom arrow, then left arrow. So our points will not given in this manner. So first is we plotted this. Now second is we will sort this. Okay, so by sorting we will get the this thing in sorted manner. Now third is we will apply binary search on answer. We know that our answer can lie from 1 till side as I have derived above. So our low will be here, Our high pointer would be here, and somewhere we will calculate this mid value. Okay, and here we need to pick k points, right? So this answer is basically saying that if this is the minimum distance I take, then how many points can I select? I mean, can I select k points? So for this mid, can I pick? Can we pick k points? Is it possible to pick k points if I take, for this mid? Basically saying, can we pick k points with limit greater than equal to this mid, right? Sorry, limit equal to mid, I would say, which says that distance is minimum distance is greater than equal to limit. So can I pick? If I can pick it, yes, I can pick it. If I can pick, then the thing is, with this limit, I was able to place my, I was able to place, pick k points. So I would say, okay, this can be one of my possible answer. So I can update, okay, with this mid, I was able to. If I cannot pick, right? So in this range, if you see, we were not, if we take this as a limit, we were not able to pick. And why we were not able to pick? Because this condition was being not met. Distance was not greater than equal to limit, right? So for that reason, uh, so is in case if we were able to pick, so if we were able to pick, we can try for, we want the maximum answer, right? So we will try maximizing it, which means we will move our low here. Okay, mid plus 1. So if possible, then we can move our low to mid plus 1. If not possible, so not possible because this condition would have not met, right? Minimum distance greater than equal to limit. It was not possible while picking k points. So for that case, we need to try the smaller limit, as in smaller distance, as our maximum answer. So this, in that case, we can move this high to here, mid minus 1. Okay. So high would be mid minus 1. Okay. Now, yeah. So this is, yeah, this is the binary search that we have to apply. Now the, you know, next important thing is this, can we pick k points with this limit? Now let's discuss this one, that if we can pick this point or not. Now let's say, can we pick k points? This is the question. Okay. Now let's say this is the point 1D array where we have our points, allocated. Let's say here it is, somewhere P1, P2, P3, P4, P5, and P6, like that. Okay. Now I have to pick K points. Let's say I started with, this P2. This was my start. When I start with this one, I know that I know one thing, that the next point that I have to, choose should be greater than equal to limit. The distance should be greater than equal to limit. So for that reason, I need to check, right, if this is the point that is greater than equal to, limit or not. If this is not, then is this greater than equal to limit or not? If not, then okay, like that I will check for everyone. But if you see one thing, that this next point that we have to calculate, this is again, these points are in sorted manner, right? This is all sorted. We have in sorted manner, and this is the points that we are going to pick. Now, I mean, think in, instead of trying, all points and then calculating, let's think greedily. Okay, if let's say this is the starting point and I have to pick k points, if this distance, if I this since this is sorted, can I know for this start, you know, limit should be greater than equal to k, right? So start plus limit. If I want to know what is the next point which is greater than or equal to s plus limit. Okay, so what is the next point which is greater than equal to limit? So since this is sorted, can we again use binary search over here? So I mean, I think we can, because we have to find this greater than equal to, and binary search is like in C++ we have this lower bound function which actually tells greater, which actually gives us address for this, greater than equal to value. So we would be able to find this next value using binary search instead of searching for everything. Okay, now let's say this lower bound gives us the next value where this limit is greater than equal to uh, I mean this distance is greater than equal to limit. So let's say this point was this one. Okay, this was the next point. Now starting from this point, now x next point I want to find is again greater than equal to limit. Let's say I pick this point which was greater than equal to limit, the next point. Okay, so this was my P1, this was my P2, this was my P3. Similarly, I will keep on finding my points. If at any point, this can be so long. Let's say if at any point I was able to, find all my points. Okay. So if I was able to find k points, basically placing point, picking. If we were able to pick this k points, then uh, what we can do is we can simply say that okay, this is possible answer, that okay, with this limit we were able to pick k points, so possible answer. If we were not able to pick, okay, no, if we were not able to pick these points, and how we will get to know that we were not able to pick this point? So one case can be, there can be two case. Okay, this was found, okay, possible, this was possible picking k points. This is not possible case. So when it would be not possible, we were saying that this lower bound will give me the next greater than equal to value. Okay, for this s plus limit. S is like the current where we are. Okay, current point. You can write it as current point. Now, if what does this lower bound give? It's the greater the next value greater than equal to this. Let's say there is no such value that is greater than equal to this value. So what lower bound gives us? It gives us the address of the end address for the array, right? So there is no, if there is no such point, for our, if there is no such next point, every point, every part we are what we are calculating, for this we calculated next one, for this one next possible answer, for this one next possible answer we are calculating, right? Next possible points were next possible point for our answer. If there is no such next possible point, which means our lower bound returned the address of the end of the address, right? So it would be array dot end, it returned. If that is the case, not possible. So this is first case where it's not possible, which means the address that it has returned, this will return some id as the iterator. So if this is equal to array dot end, which means there doesn't exist any point. So in this case, we can say not possible. With this limit, it is not possible. So we can try the next possible, basically next point where we can start off. Okay, so we initially we took this as a start, right? We could have taken this point as well as a start. We can have taken this point as well start. So with this start, I got to know, okay, this is not possible with current limit. With the current limit, with this start, we were not able to find. Okay, let's try with the next next starting point with this limit. Let's try with the next starting point with this limit. Okay, if all of this, if we calculated for all of this with this limit, it was not possible, then we will reduce the limit. That is what our binary search will do. Okay, that okay, reduce the limit and then try finding out. So here we have this starting point and we kept on finding. Okay, so this is one case when it would not be possible for us to actually uh, find the possible answer. Then there can be other case, since we said right that this would be a circular array. Okay, so our circular array would be something like this, that this is my points. Let's say I have starting point here, this is my start, there are some points over here, and this point would be the, let's say this is the next point, right? I mean, if I go circular, so for this is the next point and so on, and accordingly, if the nearest point for this is this one, right? Now the thing is, how much will I consider for my answer? So if you check this part again, if we see in this array, this was the point which is my starting point. This is the perimeter. Okay, perimeter is what? 4 times side. And let's say this is some hour, since we are going in this direction, right? This is how we are going. Now let's say there was some point over here. There is some point over here. There is some point over here. Now I know that I am considering the points where limit, the distance, that is the limit, distance should be, uh, you know, greater than equal to limit. Okay, my distance from the current point should be greater than equal to limit, right? So I considered all these points. Okay, this point from here, this point is okay, this point is okay, this point is okay. Okay, from here this point is okay. Now from here the I mean limit I have to take, right? Consider the limit. Now let's say I considered this one, because from here the limit was possible. Okay, and this is the last point. But if you see from here, this distance, it doesn't follows, because this is circular array, right? This also need to be followed. We cannot ignore this case. Here, from here, this distance limit was following, but this is not following, right? So one thing is we need to keep our end as well. Okay, meaning there can be multiple points over here, right? Let's say there can be this point also, which will follow from this point, it will follow this thing, but this need to follow this point as well. So if you see in this entire thing, what is the possible end thing, basically what is the end for this? If I start with this point, what is my ending point that is to be considered? That is my usable range, which I can use to calculate this points. I mean, I can say like among which these points I can pick these points. So there can be, this point, this point, this point, but I know that I have to pick the limit, and let's say limit would have something of this distance. So among these entire thing, I would say 4 into side, which is my perimeter, minus limit. So this is my end value, okay, for which I need to consider my answer. If anything going outside of this, then I don't need to consider my answer. And also one more thing, since we are starting from the start value, so if you see, we have to consider from here, right? So it would be plus start. In this case, start is 0, but in other cases, it won't be 0, right? So this is our end value. Okay. So now, if in our case where I mean, this was one case, right, where it is not possible. The other case is, second case is, if this end value that this point that we have calculated, right, this point, how we got this point. So now here we are at some point px. Now for this we are calculating the next point. Okay, so how are we calculating? Using lower bound. So this point y it gave me. Now this gave me this address of this point, right? So now I'll see if this point, you know, it gave me address, so I'll take this value from it, star of this. If this value is greater than my end, okay, so this was the end that I calculated. I mean, this here, this is the end, right? Like this. So if this is greater than my end, with the formula, if you see, this was my possible end because this was the limit. This is the start, which is 0. This is limit, and this was the perimeter. So this was my possible end, and this is the current end that we are coming up with every time we are calculating, right? So which, if this is greater, then this is also not possible. Okay, so yeah, this is also a not possible case. So in these two cases, if it is otherwise, we should be able to pick this. Okay, so yeah, this is how we are going to pick this, you know. And here you see this px that we are calculating every time. Here it's like current point plus the limit. So it would, you know, current point plus limit every time which we are checking the next point, and we get the next point accordingly using this binary search, and then we solve the answer. Now, I hope you get these points, and we can now let's code this out. I will, while coding, I'll just explain this entire thing one more time for better understanding. Okay, that what and how we are doing. So, what we did was the first step here. If you see, this was our first step where we are changing our 2D array where we have given the points in the Cartesian plane. We are plotting these points in the 1D array as a single line. Okay, so for this we need to have this array where we need to store these points, you know. So we will create these points. Also, one more thing to notice that every time when we were calculating the points, right? So if you see these things, here we are doing side plus x, 3 times side plus x minus y, 4 times side. So the constraint is side can be up to 10 to the power 9, right? Now if we multiply 4 into side, so that would be greater than the integer limit. Okay, so to consider that situation, every, you know, the variable this we are taking, that would be, I mean, every data type that would be taking it, it wouldn't be integer, it would be long, because 4 into that side can be greater than the maximum integer limit. Okay, so let's write this out. So for long, I would be taking ll as, you know, long. So this is my vector long of array, and I want the maximum answer as well, so I would keep it as answer equal to 0. Now I have given this points, right? So I need to plot my points. This is the first step. So auto, so here x would be p of 0 and y would be p of 1. So this is x and y for every points. Now we will write the same thing. If x is equal to 0, our array dot push back y. Okay, else if y is equal to side array dot pushback side plus x. This is the same things that I'm writing, which I already discussed above. Okay, so x is equal to side array dot pushback 3 into, since we are doing long operation, right? So I have to explicitly write it as 3ll into side minus y, else, that is the last case where basically y was 0. So in that case 4ll into side minus x. Yeah, so this is the first step that is done. Okay, this was my first step. Now second step was sorting this to get all our points, in sorted array. So we will sort array dot begin. This is the second step that is done. Now third step was applying the binary search. So again we will have this long low is equal to initially 1. This is our range starting from 1 for our answer. Now high would be sorry, yeah, high would be side. Okay, now I'll apply this binary search. This is the general template of binary search. Here I can write simply as long mid equal to low plus high minus low by 2, and if this is the check, can pick k points with limit. Okay, so here I will pass mid. With this limit as mid, can we pick k points? If it is possible, then this can be my possible answer. So I will update my answer with mid, and my low value would be mid plus 1. If it is not possible to pick, then I need to reduce my limit and then check, right? So it would be high equal to mid minus 1. So this is my binary search that is done. And at the end, I can return the answer that I have calculated. Okay, now let's write this method. So this is a Boolean method. Can pick k points with limit. Okay, so we have this long limit, and since this method is outside of other our method, we can have this array and side and k other parameters, whatever needed, we can get this passed. Okay, so similarly here also we can pass those things, whatever is needed. Now this is the array. We can take this in as array dot size, and we need to iterate on this array for all the starting points. Okay, so for int ind is equal to 0, ind less than n. Okay, so uh, my long start is equal to array of ind. So as I told, right, so we will try every point as a starting point, and we will keep on uh, finding the next. If I have one starting point, I will keep on finding the next possible points, and I will keep on doing until either I am able to pick k points basically, or I was not able to pick. If not possible, then maybe I will try with other starting point, next starting point, and then I'll keep on doing it. So this is the my starting point, this is trying out all points as starting point, and from there we will pick all the points where the next point is greater than equal to whatever limit that the distance is greater than equal to limit basically. So this is start, and accordingly we need to calculate end as well for the circular case, so that our end should not be greater than this. I mean, we should not be able to pick something outside of the range. So our usable range that we calculated here, if you say, yeah, this is our usable range, right? That perimeter minus limit is where which we can use, and this is the starting point. So this is what my end is. That my end should, this we are calculating to check that our end should not, our next point that we are getting every time, it should not be greater than this end. 4 ll into side minus limit, and then long that is current point would be initially at start. Okay, so this is my current point where I'm starting. This is start. So which also means that I have picked one point, which is the starting point. Now I need to pick the remaining k minus 1 point. Okay, so for finding the remaining k minus 1 point in this our array, we need to find the remaining k minus 1 point. Okay, so it is for I is equal to 0 till I less than k minus 1. Okay, we need to pick these many points. Now we would use our binary search, lower bound, array dot begin, array dot end, and current plus limit. Okay, so as he explained, right? So if this is our point in Cartesian plane, this is our point. I need to, and these are so many points next. Okay, and let's say the limit was, in this case, let's say the limit was 2, right? So if I am at point this, a limit was 2, and the next point that I need to find is, right, current plus limit. Okay, in this array, current plus limit would be this one, or I mean, it would be these ones, right, which is greater than equal to, but this is the first point uh, which is has this current plus limit. So we need to find this point. So if id is equal to array dot end, which says that there is no points which is greater than equal to current plus limit. Okay, or this it that we got the value, right, that is greater than end, the end value that we have calculated here. If it is greater, which means that we cannot find further any points, and we can take make our current as -1, indicating that no further points can be find, and we can break from here. Okay, and if we were able to find the point, okay, next point, so we will place our current at that next point, and similarly we will keep on calculating next point. So now our current point at that next point, now for that next point we will calculate the next point. We'll keep on calculating this next point until we find this k minus 1. Now here we have breaked, right, and we have marked this current as -1. So here we will check if current is equal to -1, which means, or I can simply say, no, same, I mean, it will work if it is greater than equal to 0, which means, sorry, my bad. if let's say I kept on calculating, and at the end I was able to calculate everything, and my condition didn't came here anytime, which means that my current would be greater than equal to 0. So if current is greater than equal to 0, which means I have found the answer. I was able to pick uh, k points, and I can return true from here. And if not, then I will calculate for the next starting point. Okay, next point as the starting point. And if that is the case, I can return. I mean, if I tried all the starting points, all the points as starting point, and kept on finding next points from that point until we can pick the k points, and if we were not able to find any such, points with the current limit, then we can return false from here, saying that with this limit we were not able to pick the points. So we have to further reduce the limit so that we would be able to pick k points. Okay, so this is the approach for this. I hope you understand. Now let's discuss the time complexity for this approach. So first one is like we are running one loop over here, so it is like points, I would say. So we can say that if there are n points, so this is O of 1 for calculating these points. Then we are sorting, so it is n log n, this one. And then we are doing binary search over here. So altogether binary search on side, right? It is max upside. So it is log of n. But inside this, if you see, we are having this method. So how much for each of these points it would take? So log n into, now let's calculate for this method. So this is one method which goes for the array, and array would be of length, all the points which is of n. So it would be again for n times. Then for n times, we are having this loop running k times for finding the points, for which we are finding these points for inside this array, which is for log n. So this for individually, this method altogether would take n into k log n. And here, if you see, we are doing this for, this is, sorry, my bad, not log n, this is log of side. So into whatever into this one. So it is, time complexity is log of side into n into k into log of n. This is the time complexity. Or if we write it simply, so it would be O of n into k into log of side into log of n. And space complexity, if we see, so additional array we are taking to store all the points, all the transfound points, so it would be O of n. So yeah, this is about space and time complexity for this approach. I hope you liked it. Thank you for watching. Stay tuned for next video. Thank you.